Okay, we'll look now at the trapezium rule. Now, the trapezium rule used to be on the C2 paper, so whenever you're looking at past paper questions, that's where it was, and it's been moved to upper sixth for some reason now in this spec. So it's used to calculate definite integrals or the area under a curve, and they're generally things that you can't integrate at this point, okay? So a few things just to remember about this. Always do your work to at least 4 decimal places and only round whenever you give your final answer. Okay, so at least 4, if not more. Questions involving trig are always in radians, and you're given the formula in the formula booklet, so there's no excuse for not filling it in correctly. Okay, so I'm going to show you where the rule comes from and what all the different letters stand for. Okay, so if you consider this curve f of x, and we want to find the area between A and B. If we don't know how to integrate, so you would normally say, well, the area equals the integral from A to B of f of x dx. If you don't know how to integrate whatever the function is, or if you're told to use the trapezium rule, if you imagine we divided up this area into different strips, all of equal width, okay? If we could find the area of each one and then add them all together, we would get an approximation for the area, okay? So there are n strips of width h. Okay, so this width here is h. Now, if you consider just one strip, what we're sort of assuming is that we're looking at a small enough part of the curve that it's really a straight line, which would form this yellow trapezium here. Okay, so each strip is roughly the shape of a trapezium. So if we call our first ordinates, remember coordinates are where your x and y are together. So if you're just talking about one of them, it's an ordinate. So we'll call that x0, then x1, x2, etc. And this will be right up to xn. Our y values then up here will be y0, then here y1, y2, all the way over to our y value here, yn. So if we look at the first trapezium there, the yellow one, well, we know the formula for the area of a trapezium. It's a half upon a plus b times h. So our a and our b are our y coordinates, y0 and y1, and our h is the width of it, which we've said is, we'll just call it h. So if we add up the area of n trapezium, that's just the plural of trapezium, we'll have the first one will be y0 plus y1 times h, second one a half upon be y1 plus y2 upon h, etc, 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 right up until the last one, which will be yn minus 1 plus yn times h. Okay, so the first thing we're going to do is take out a half and n as factors. So we can say now that area is approximately equal to, we're taking the half and the h outside the bracket, we're left with y0 plus y1 plus y1 plus y2, etc., up to yn minus 1 plus yn. Hopefully you can see that all of these ordinates all will appear twice, except y0 and yn. So these will only appear once. So our formula is going to be y naught plus yn plus 2 times then all the other y values. And that's the trapezium rule, okay? And so that's given to you in your formula booklet. So first of all, the wavy equal signs just mean approximately equal to. And then the questions will either use strips or ordinates. Okay, so you need to know the relationship between them. So if we have 6 strips, that will give us 7 ordinates. Okay, if we'll have 7 strips, it would be 8 ordinates. So if we have n strips, we have n plus 1 ordinates. And then the other thing, and this again is given to you in the formula booklet, is our height, h, is found by b minus a, which were our limits for the area, over n, which is the number of strips. Okay, so our first example, use the trapezium rule with 5 strips to estimate the integral between 1 and 6 of x over 1 plus x squared dx. Okay, so the first thing to do then is find h. So it's going to be b minus a over n, so that's 6 minus 1. Okay, so our b and our a are our limits, and we've got 5 strips, so 6 minus 1 over 5. So that gives us that the height is 1. Okay, so that's the difference between all our x values. So that means our x values will start at 1 and they'll go up in 1. So 1, 2, 3, 4, 5, 6. And hopefully you can see with 1, 2, 3, 4, 5, 6 ordinates and 5 strips. And now we want to find the corresponding y values. So y is found by getting x over 1 plus x squared. So we do 1 over 1 plus 1 squared and we get 0.5. Then put in 2, 3, 4 gets a bit messier. So again, remember to do it to at least 4 decimal places. I've done it to 5 here. Okay, so let's put in all our x values in to find our corresponding y values. Then to put it in the trapezium rule, now this time it's not saying find the area, it's just saying approximate this. So this is approximately equal to half times h, and h we said was 1, plus the first ordinate and the last ordinate, plus 2 times all the ones in between. So we've got a half times 1 is a half, and when we work out all what's inside that bracket, we get 2.91738. So we get 1.45869. And depending on the question, sometimes these questions will say, give your answer to 4 decimal places or 5 decimal places instead of the normal 3 significant figures. But if we put it to 3 significant figures, it would be 1.46. Our second example then, use the trapezium rule with 5 ordinates to find an approximation for the integral between 0 and 1 of sine 2x dx. So this time it's telling you how many ordinates. So if there's 5 ordinates, that means there are 4 strips. Okay, so find h first of all, which is b minus a over n. So that's 1 minus 0 over 4. So it's 0.25. So our x values will go up in 0.25. So we'll start at 0, 0.25, 0.5, 0.75, and 1. And we have our 5 ordinates then. We want to get our y ordinates then. So y equals sine of 2x. Now remember, this is trig, and trig in the trapezium rule always radians. So first one, sine naught equals naught. I would write that one as naught. The rest of them I would just write in this table as sine 0.5. Remember, it's 2 times 0.25. Then 2 times 0.5 sine 1. 2 times 0.75 sine 1.5. And the last one sine 2. I wouldn't work them out as decimals here. Just keep them as the exact values there. So now when we integrate or find our approximation using the trapezium rule, it's a half times h, which is 0.25. The first y value is naught. The last one is sine 2 plus 2 times all the 1 in the middle. So sine 0.5 plus sine 1 plus sine 1.5. So a half times a quarter, we've got an eighth there. When we put all that into our calculator, we get 5.54608, which gives us 0.69326, which if we were doing it to 3 significant figures, it would be 0.693.